The scaling screen under the axis is what defines how many motor revolutions per user unit there is. We selected the units under master, but under scaling for the axis is what defines how many motor turns per inch there are. So we have different transmissions available. This will help calculate what these would be. And then under the reducer, we also have an optional reducer as well too. Under a lead screw, for an example, if you had one, that's fairly straightforward and easy. That would be 1 motor turn equals 1 inch. This is actually multiplied by the step resolution of the motor, which is 51,200. So 51,200 would give you 1 motor revolution, which would give you 1 inch. So that would correspond in the system code of an axis PPU of 51,200. That's how we come up with that number. And so the controller doesn't know inches or lead screw or the gear reduction. It's just using this to calculate the PPU of the number of pulses per user unit. If this was a 0.2, which is a 5 rev per inch ball screw, then it would be 5 motor turns is equal to 1 inch. And let's say we had a belt reduction of a 2-to-1 between the motor. So the motor pulley would be half the size of the pulley on the lead screw. And so then the lead screw would also need to turn 5 revs per inch. So that would give us overall 1 motor revolution is equal to 1/10 of an inch. So we would have to turn the motor 10 revolutions for 1 inch. So that multiplied by the step resolution, so that would give us 512,000 microsteps per 1 inch. We give different transmissions available, conveyor, lead screw, rack and pinion, rollers. And new to Parker Motion Manager, we have now added the actuators and precision stages, as well as the rodless actuators. So this helps programmers not familiar with the part numbering of the actuators. You don't have to go to the catalog to look up what the transmissions mean now. So if you had, let's say for an example, you have an OSPE actuator. This is a ECLM stepper motor on it and an OSPE 25. So I would come into an OSPE, and under the order code we can see the 25 and then 3, since we do have the 3 in the part number, and that would specify the lead screw. I don't have a gear reduction, it's directly in line, so I would set the reducer to none, and that would calculate the inches per revolution of the motor. We also have the rodless actuators, and these commonly are belt driven. Some of them are screw driven, in which case the belt driven system, the motor will be orthogonal to the transport belt. So this saves you some time of having to look up in the catalog the inches per motor revolution, if you will. Commonly, belt-driven actuators will also have a gear head on there. Also on the ETH, they're an option as well too, which is a rod-type actuator for higher forces. If you, under a reducer, you have a Parker gear head, and then you can specify PS, PX, PV. These are the inline gear heads, and then you also have the RS and the RX, which are the right angle gear heads as well. These are all fairly straightforward. The order code in the part number is 003, as an example, is an exact 3-to-1 ratio. A 007 is an exact 7-to-1 ratio. and they go all the way up to 100 to 1. Now, the other thing is that if you are in units of revolutions, we also have a rotary table, so you can specify a rotary table, how many motor revolutions input for one output revolution of the rotary stage, or we also have the Parker rotary positioners as well too, already predefined, just like the linears. So that'll help save you some time on there. But overall, this screen is just calculating the number of motor revolutions to the user units that you'd selected.